Okay, good day again to everyone. Our focus today is the continuation of our lesson that is on ellipse. Before I'm going to discuss this continuation of our lesson, now may I just encourage you to please watch the whole video for you to understand the lesson. Now, another one is may I encourage you also to kindly support this undertaking by what? By clicking the subscribe button now, and then of course by liking it, making a comment, making a question, writing them or typing them on the comment section of this channel, and I will be very glad to answer them. Or if you cannot type them, now you might approach me and ask something. Okay, so that will be the support that I am asking you by simply watching them, and after that one, by clicking the subscribe button, and then by appreciating them. If you appreciate it, then you might as well like it, click the like button, and if you want to ask something, then ask something. Okay? So I hope with this simple undertaking, simple video presentation, I can help you by my dear students. Now, last time we defined the ellipse. We have said that the ellipse is the locus of all points in a plane, such that the sum of their distances from two fixed point in the plane is constant. Okay? So what is the fixed point being mentioned in here? That is actually the focus of the ellipse. Now we have two focus of ellipse, and so those focus are called to be foci. Why? Foci is the singular form of the word focus. Okay? So in ellipse, there are always two foci that is defined by our computation soon. Okay? When we compute the value of C, now you will notice that we have the proper relation of the focus. But mind you, my illustration in here is an ellipse that is with a major axis that is in line with our x-axis. Another one is my ellipse in here is with a minor axis that is in line with the y-axis. So notice that when I'm going to label the Cartesian plane, I have in here, this one must be 1, that is 2, 3, 4, 5, and 6. Having this labeling, now I can label all the different parts. Okay? So that also we can make use of those labeling in the combinations. So my negative x-axis, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. How about in here? That is the same as negative 1, okay, negative 2, negative 3, negative 4. How about in here? This is positive 1, positive 2, positive 3, positive 4. Now having this different labeling, now we can now assign the value of our A. But before that, when we say major axis, the major axis is defined by the value of A. So last time I told you that the distance from the center of the ellipse going to this vertex is called to be A. How about this one? The distance from the center going to the left side, that is under the x-axis, that is another A. So the measure of this vertex passing through the measure of the segment passing through our center going to the opposite vertex is called now to be our major axis, and the measure of that one is 2A. 2A. Why? Because we have A. So again, A is measured from the center to the vertex. A is measured from the center to the vertex. So the major axis has a measure of 2A. And then A plus A, and that must be 2A. Now, another one is here the minor axis. Our minor axis is the shortest axis of the ellipse. Where is that? We have in here. So the measure of our minor axis is actually 2b. Okay? So 2b. Why? Because the measure coming from the center going to this vertex is actually b. That is actually b. Another one, the measure from this center going to this one is actually b. Okay? So, meaning, if I were to add this one, the general measure of the minor axis, that is the same as 2b. Now, what about if we just say b, just a? Meaning to say, if we just say a, that is considered now to be semi-major axis. The semi-major axis is actually the half of 2a or half of the major axis. We have also semi-minor axis, which is just a measure of b. Why? Because the semi-minor axis is actually the half of the minor axis. Okay? So again, the measure from the center going up is b. The measure from this center going down to this vertex is b. So with that, if I have to get the total, I must be having 2b. b plus b is 2b. Notice that I calibrated the Cartesian plane. Okay? I calibrated the Cartesian plane having this Cartesian plane 1, 2, 3, 4, 5, 6. Another one, -1 until -6. That is 1 until 4. That is -1 until -4. Now, what is the use of that? So that when we are going to look into the vertices, okay, the vertices without the number, without the calibration, the vertices in here can be named, okay, by using the alphabet A, B, C, or the A and B. Now, if I were to get the name of this one, assuming that we do not have calibration, what must be the name of this vertex? So you will notice, if I have to name this vertex, the vertex is actually the intersection of our major axis and then the ellipse is actually a vertex. So we have two vertex along the major axis. We have, what is the vertex? Well, how do we name this one? This must be what? Vertex. Normally, our vertex is a point that is the same as x and y. So that if I were to name this vertex, my x is actually has a measure of what? A. Yeah. So has a measure of a. Notice that my vertex in here corresponds horizontally to the point of origin. So meaning to say my y in here is 0. 0. Another one is, what must be the vertex in the side? That must be the vertex is still represented by x and y. Where is that? You will notice our x in here is, what is that? -a. Why? Because it is at the left side of the point of origin. So that is the same as negative a. Now notice that this point corresponds horizontally to the point of origin. So what must be my y? My y is 0. So that is the vertex, or those are the vertex under the major axis. Now what about if we are going to have the labeling for calibration? Now we already calibrated. Can we give the actual coordinates of this one? Notice that when we get the actual coordinates of our vertex A0, we have in here vertex A and 0. That is the same as what is our A? What is our A? That must be 6. 6 correspond to what? Correspond to point of origin, which has the value of y that is the same as 0. Okay? Now what about the vertex of this one? The vertex of this one is same as negative A. Why negative A? Because this measure is at the left side of the point of origin. So we have negative A. Now what is the measure of the negative A? That is actually 6. So meaning to say, because that is located at the other side, we have negative 6. And of course, that vertex corresponds horizontally to the center of the ellipse. And so that is 0. Okay? That is 0. Now, what about these vertices? Now, notice these vertices are actually along the y-axis or under the minor axis. Okay, minor axis. Now, again, what is the name of this vertex? Notice that when I will name this one, again, I will follow the style of the coordinate system, which is point is always x and y. Okay? Now, what is our x? Our x in here is actually this point. Our x in here corresponds to the point of origin, wherein the x is 0. The x is 0. Actually, we have in here a 0. Now, what is the measure of this one? What is the measure of our y? That is the same as b. And so I have this one, 0b. Okay? Now, the same as in here, what must be the name of this vertex? That is again, notice that my x is 0. Why? Because this point corresponds vertically to the point of origin, wherein the x is 0. So I have this one, x is 0. But notice that if I have this one, I have a measure that is the same as the b. But because that measure is located below the point of origin, that must be negative b. Okay, negative b. Okay, so the vertex is 0, negative b. Now, notice that we calibrated our Cartesian plane. And so we can now give the actual vertices that is created by the minor axis. Especially this one. Okay. So what is that? What must be the y in here? That is the measure of our b is 4. But it corresponds in here, corresponds horizontally to this point. That is our x is 0. So we have in here 0 and 4. How about in here? Our x is 0. Our x is 0. So we need to say our coordinate is 0. What about our y? Notice that this has a measure saying that is 4, but located below the point of origin, and so that must be negative 4. Okay? So here are my vertices. When we are talking of ellipse, we always consider 4 vertices. Now, are these points important? Yes. They are very much important. Why? Because having the value of A, that's the time we can locate accurately the location of the focus. We can locate the location of the focus accurately. By what? By computing the value of C. Okay? By computing the value of C. Now notice that when we say C in the ellipse, that is actually the measure. C is actually the measure of the segment coming from the center going to the expected focus. So that is our C. So we need to say C in here is our problem. Okay, C in here is our problem, so that by getting the value of C, that will lead you now to the accurate location of our focus. Okay, so meaning the question is, where is the focus, or where are the foci located in our major axis? Again, we cannot locate that one immediately. Why? Because we need to compute for the value of C. Again, what is the C? The C in the ellipse is actually the measure of a segment coming from the center of the ellipse going to the focus. going to the location of the focus. But again, as I said, our C is unknown. So that must be our focus today, or our concentration today, to look for the value of C. Okay? So to look for the measure of the Z. Now, to get the measure of the Z, we are going to follow this working equation. So C squared is equal to the difference of A squared and B squared. Again, to look for the value of C, we are going to use this working equation, that is C squared is equal to A squared minus B squared. Okay? Now notice that in our illustration, the given are just the A, the value of A, and the value of B. The value of B. Now, so to get now the value of C, we are going to use this one. Why? Because, as I said, our A is actually what? Our A is 6. Our B is 4. By substituting this one, then we can have C squared is equal to 6 raised to the second power minus B, that is 4, raised to the second power. So our C now, C raised to 2 is 36. 36 minus this one, that is the same as 16. Now what would be our C? Our C now is the same as C squared is the same as that is the same as 20. Are we done? Not yet. Why? What are we looking in here? What are we trying to compute? What we are trying to compute is actually the value of C, not the C squared. So what is that? Or how are we going to do that one? We extract the root. So extract the root of C squared, square root. That is the same as doing also on the other side. So that must be what? That must be the square root of 20. The square root of 20. Okay, so let's continue. Now what must be the square root of C squared? The square root of C squared is C. Now what must be the square root of 20? That is actually 4.47. And so that is the value of our C. That's the value of our C. Now, where is that located? Or what is the use of that C? What is the use of the C? As I told you, the use of the C is for you to locate the accurate location of the focus. Okay? Why? Because the C is actually a segment measured from the center of the ellipse going to expected focus using the 4.47. Now where is that? That is 1, 2, 3, 4. 0.47 is almost half. So most probably our focus is located in here. From this point, going to the center is the measure now of our C. It is actually the measure of our C. So we say this is our C, which is 4.47. 4.47. Now using the 4.47, counting that one from the center going to 4.47, that is our location for our focus. This point is our focus. The same true that we measure this 4.47 on the left side. So most probably the location is in here. Okay? So our C in here our C is 4.47. Now, this must be again our another focus. We say this must be our focus, and that must be termed as focus 1. Okay? The same as in the left side. That must be our focus 2. We measure the C by having this 4.47. So from the center going to this one, more or less, that must be our 4.47, which is now our focus 2. Our focus 2 now is in here. Okay? Now, can we have now the different coordinates of this focus 1 and focus 2? Yes. Why? Because we have now the value of C. So our coordinates for our focus 1 is actually, focus 1 is 4.47 and 0. How about the focus 2? Our focus 2 is negative 4.47 and 0. See? That is how we are going to compute for our focus, or that is how we locate our focus. First, we should have the value of A and B. Second, if we do not have the value of C, definitely you cannot locate the focus. And so, what are you going to do? Compute for the value of C by making use of our working equation. So our working equation is C squared is equal to A raised to 2 minus B raised to 2. Now use this one by substituting the value of A and B, and then after that one, squaring them, get their difference, and having the difference extract the root of that one. That is the same as what we have done in here. So the square root of 20 is 4.47. So having the value of C, we can now accurately locate the location of focus or the foci, focus 1 and focus 2. Okay? So after that one, we can now get the actual coordinate of our foci. I hope you understand the lesson. The next lesson will be the verification of this statement. You know, we cannot verify immediately this measures or this. We cannot verify immediately this statement under the definition of ellipse. We can only verify that one, the sum of the distances from fixed point in the plane is constant if we have already learned the value of A, the value of A, the value of B, and the value of our C, the value of our C, so that we can locate the foci. After having that one, we can now verify the definition of the ellipse. Now, the next thing that we're going to look into now is we can now locate the focus of the ellipse that we have after knowing now the value of C that we just computed. Notice that the value of C that we have in here, we computed the result that is the same as 4.47. So where are the location of our focus? Now, most probably we have said that the C is a measure from the center of the ellipse going to the expected focus. So most probably our focus 1 is defined by the value of C that we have. Now what is our C? That is the same as C is 4.47. That is almost 4.5. So most probably the location of our focus is we have in here. So maybe call that one to be our focus 1. The same true that when we are going to look for the focus 2 that is located at the left side, we might as well consider this one as our focus 2. So focus 2. Now, what are the numerical coefficient or what are the coordinates of our focus 1? Now, meaning we have now a coordinate in here that is the same as 4.47 as our x, which was this measure, and that corresponds to the point, the center of the ellipse, so that is the same as y is 0. So our focus 1 is 4.47 and 0. What about our focus 2? Our focus 2 in here is the same as negative 4.47 and 0. So that must be our focus 2. So negative 4.47 and 0, because that is located at the left side of the center of the ellipse. Now, last time we are trying to say that the sum of the distances from the two fixed points, which is the focus 1 and focus 2, to any point is constant. Meaning to say, if we have another point located on the circle, and we are going to connect focus 1 to that point, focus 1 to that point, and get the sum, it is constant. And that is what we are going to verify, because we are now having the different values in here. Now consider that our point A is located in here, the vertex itself. That is, our point A is 0 and 4, so we have in here as our point A. Another one is point B. Our point B here, the vertex in here, that is the same as 6 and 0. Those points are all located on the ellipse itself. Now, if we are going to connect the point A, we will connect the point A going to this one, and that must be connected to the focus 2. Now, the result of these distances plus this distance is actually constant. That is the same as saying when we are going to compute point A going to focus 1 plus point A going to focus 2, the result is constant. Now, for our concentration in here is to look for the value of that constant. And how are we going to look for the value of that constant? Now let's try to have. What is our point A? 0 and 4. What is our point B? That is 6 and 0. And so, when we are going to verify this one and look for the constant, we might as well compute the value or the distance of point A to focus 1. By what? By using the distance formula. What is our distance formula? That is the same as x sub 1 minus x sub 2 raised to the second power plus y sub 1 minus y sub 2 raised to the second power. If we are going to replace this one, extract the root, and that must be the distance between point A to focus 1. So now, let's try to have what must be the value of our x sub 1, which is the value of or the coordinates of point A. So our x sub 1 in here is 0. So that is the same as 0 minus what must be the coordinate of focus 1? X coordinate of focus 1. That must be our minus 4.47. Okay, so that is the same as 4.47 raised to the second power. Now, next is, of course, their values in their y coordinates. Okay, now what must be our y1? Our y1 is 4. Okay, our y1 is 4 minus our y2, that is the same as y2, that is 0. Okay, so we have in here now the equation after replacing them, That's the time we are going to have the result. So what must be the result of this one? That is the same as we can now have the square root of negative 4.47 raised to the second power. What about this here? That is the same as 4 raised to 2. And so it will give you now a result that is the same as what is the square of negative 4.47? That is the same as 19.98. What about this one? That is plus 16. You are going now to add them. So meaning, if we are going to add, it will give you now a result of the square root of 98. Now, what is the square root of that one? The square root or the result of that one is 5.998. Okay? So I will round this one to 6. But meantime, I will use first the one. I will be rounding off them after the final result. Okay, so meaning to say the distance of point A to focus 1 will be 5.998. Okay? So what about the distance of point A to focus 2? We do the same. So that is the same as, let's try to have our equation so that we will be reminded. So what would be our equation? Still the square root, okay? The square root of the quantity x sub 1 minus x sub 2 raised to the second power plus the quantity y sub 1 minus y sub 2 raised to the second power. So again, we make use of the same working equation. Now, notice that when we are going to have the result, what must be our A? What must be the value of x in our A? That is the same as our A is actually that is the same as 0. Okay? Minus what must be the value of our x in focus 2? That is the same as negative. So we have negative 4.47 raised to the second power. Okay, raised to the second power. Now next, plus, that is the same as what must be our y sub 1 in point A? That is the same as 4 minus y sub 2 in focus 2. That is the same as 0. That is the same as 0 raised to the second power. Now, considering that one, we have now a result that is the same as the square root, okay, the square root of positive 4.47 raised to the second power, that is the same as plus 4 raised to 2. Now, notice, they are about the same in here. That our result would be the square root of what is that? 19.98. How about this one? Plus 16. And so, if you're going to add them, it will give you now the square root of 35.98. And what is the square root? They say the square root is the same as 5.998. So meaning to say the distance between point A to focus 2 is the distance between point A to focus 2 is the same as 5.998. So this one, okay? Now, what about the distance between point A to focus 1? Saying that is the same as 5.998. That is almost 6 if you're going to round it off. Now, it says in there, what is the value of the constant? Meaning to say, to look for the value of the constant, we are going to add them now. And the distance between point A to focus 1 and point A to focus 2. Now, what must be the distance? The distance that we can have in here now, the distance is a point A to focus 1 is equivalent to 5.998 plus the distance of point A to focus 2, that is 5.9998. And so our result now, our constant now in here is 11.996. That is the same as 12. Actually, that is the same as 12. Now, notice that the constant that we computed is, what is that? 11.996. Now, meantime, we do not say the constant is 11.996. Why? Because we need to verify using the other point. Meaning to say we are going to compute again the other point. Now, would it give you the same result when we are going to get or compute the distance between point B to focus 1? And so meaning, what we are going to look into is the distance. Okay? So we are going to have this one. Focus 1 to point B. Okay? So we are going to have this result. What must be this distance? Another one is we are going to add this distance, the measure of this one, from the measure of focus 2. So our focus 2 is actually located in here. So where is that? I might as well have this one, okay, to verify. And so we need to say accordingly, what is the measure of this focus 2 to point B? That if you are going to add this measure to the result of point B to focus 1, it will give you a constant result. Now, it will give you the same result. Now again, let's try to verify. Okay? Let's try to verify if it will give you the same result. So meaning, let's try to have our point B. Okay? Let's try to have it one by one. Point B to F sub 1. Now, what is our working equation? Our working equation is the distance formula again. Okay. Now, what is the distance formula? X sub 1 minus X sub 2 raised to the second power plus y sub 1 minus y sub 2 raised to the second power. Now, next, let's try to have the square root, okay, of the quantity X sub 1. What is the value of x in our point B? The value of x in our point B is 6. And the quantity 6 minus what must be our x in focus 1. Okay, focus 1. So our x is the same as 4.47. And that is raised to the second power. Raised to the second power. Plus, now we have in here y. What is our y in point B? Okay, point B, that is 0. Okay, that is 0. Minus, what about our y in focus 1? Focus 1, that is 0. Okay, 0. So meaning, the result is the same as the square root of, what is the result of this one? That is the same as 2.3034. Now, extracting the root, that is the same as 1.529. Okay? Or that is the same as 1.43. So that must be the result, the distance the distance of focus 1 to point B. Where is that located? The distance of focus 1 to point B is part. Okay? This part. The measure of that one is 1.50 2.29 or 1.53. Now, what about the distance of point B? And point B to focus 2. Now we follow the same working equation. May I immediately substitute the working equation? So what is the value of x? What's the value of x in point B? That is the same as 6 minus what is the value of x? What is the value of x in point F2 or focus 2? X negative 4.47. That is raised to the second power. Plus, what about dy? Okay, what about dy? Now, what is dy sub 1 of point B? 0. Okay, that is the same as 0 minus. How about dy in focus 2? That is the same as 0. Okay, that is the same as 0. And so we have now in here the substituted value. Now, after having that, this is the same as 0, but this is already 10 the square root of 10.47 raised to 2. Now, raised to 2. That is the same as after having that one, we are going to raise it to the second power, and so it will give you now the square root of 109.62. 109.62. Now, notice that we need to extract the root, 10.469. Meaning, this result is actually the measure of from point B to focus number 2. Now, where is that in our illustration? That one is located in here. That is the same as point B from here going to focus 2. So what is the measure of this one? It will give you, that is the same as 10.469. Now, after having that computation, that's the time we are going to verify. Okay? What must be the result? What is the result of this one? That is 1.529 plus, how about in here? That is the same as 10.469. Okay? So that must be the result. And so if you are going to add that one, it will give you now, that is 11. Okay? 11.998. Okay? 11.998. So that must be the result of our computation. Notice that when we are going to have the result of the other one, they are back of the same. When we are going to round them off, this must be the same as 12. Okay? 12. What about this one? If we are going to round it off, that must be 12. Are they the same? Yes. Meaning, if they are the same as constant. The value or the verification now of our definition of the ellipse, which states that the distance between two fixed point to a common point, okay, the distances between two fixed point to a common point will be constant, and what is the value of that constant? That is 12.